So last class, hello, is it audible? Hello?
Yes, sir.
Okay. So last class we discussed about DFT, right? Computing 8-point DFT. We focused on the relevance of capital N in an endpoint DFT. So the conclusion was that when you increase the value of N, your magnitude spectrum, the resolution of the magnitude spectrum will improve. And if you choose a capital N value, which is less than the total length of the sequence, that means N less than L, then what will happen? You will have aliasing in time domain. So we have visualized all these things in the last class. And today we will focus on two things. First thing is, I will try to wind up in next 20 minutes. Okay. First thing is you have to find, you have to learn a shortcut method to find 4-point DFT. You can apply it for any point DFT. So we will limit it to a 4-point DFT using a matrix method. That is the first task. We'll do one problem on that. And second task is to find the inverse DTFT. We will discuss about the equation, how to find inverse DTFT. Others, please mute the mic. So first topic is we will study a shortcut method. We can do this using calculator also. We will discuss in one another section that. Okay. First, let's try this method, matrix method. This thing you can apply in your during your exams also. So to compute a 4-point DFT, you are going to use a shortcut. For that, you have matrix. Before that, let me introduce you a term called a Tudel factor. It's called Tudel factor. This will be used while computing FFT, fast Fourier transforms. Okay, we'll discuss in detail later. Anyway, nothing is there. It's WNK. It's represented like this: WNK. So WNK is nothing. E raised to minus j 2 pi k by capital. So this was the factor that we have seen in the DFT equation, where you had a small n over here. That was the DFT equation. Same thing, e raised to minus j 2 pi k by a. That's it. I think the term is clear to you, right? So this is the matrix that you are going to calculate, or that you are going to use to find a 4-point DFT. The pattern goes like this. This is the matrix. W. Always here you have n. N in our case it's 4. Okay, so it's W40. Fill like this. It's a 4x4 matrix. W40, W40. Okay. Then bottom also you have to fill W40, W40, and W40. So this is the first line. All are zeros, right? Second line, it will be 0, 1, 2, 3. So this is 0, this is 1, then this is 2, and this is 3. Third line, it's next multiple of 2. So it's 0, should start with 0. 0, 2, 4, 6, right? Multiple of 2. 4, 6, let it be W46. W46 is same as W42. We will look at that. So next multiple of 3s, starting with 0. So 3, 6, and 9. This is the general matrix that you can use to find 4-point DFT. It's clear? So let's see how can you find DFT of a sequence. See, for example, if you want to find DFT of a sequence x of n. So this can be used to find for a sequence of length 4, right? Assume that my x of n is 1, 1, 0, 0. This is the one which we have tried using other methods also. So let's do that and verify the answers. So this is your sequence x of n. You just multiply these two matrices so that you will get the result capital X. So first element is denoted as x of 0, second element is x of 1, third element is x of 3, and fourth element is x of 4. Let's verify the dimension. This is a 4x1 matrix. It's a 4x4 matrix. This is again 4x1 matrix. So product of this thing will be a 4x1 matrix. So that's valid here. So this will work. Clear? Now let's find the values. during exam, you can directly use the matrix values. Please help me to find the values. Okay. First one, W40. W40 means, let's find over here, W40. Is it visible to you? Okay, so W40 is e raised to minus j 2 pi, do it fast. 2 pi into 0 by 4. So e raised to 0, that will be 1. So all W40 can be replaced with 1. So that's pretty easy. So 1, 1, 1, 1, 1, 1, sorry, it's not 1. 1, 1, 1. Isn't it? So fill 1 like this. This particular column and this row. Completely one fill here. Now remaining thing is 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 positions. So W44, this will also be 1. W44. After you have a property like this. W, say capital N, okay, WN K. This is equal to WN K plus N. After capital N values, it will repeat. So W40 will be equal to what? W44. Then this will be equal to W48, W412. All values will be same. That will repeat. Got it? After 4 values, that will repeat because the index is 4 only. That's because of this exponential term. So W44 can be equated to W40. So this term will be again 1 itself. Now let's find the remaining terms. Next, let's find W41. So find the value of W41. E raised to minus j 2 pi k is 1 by n is 4. So e raised to minus j pi by 2. So that is cos pi by 2 minus j sin pi by 2. So that will be minus j. Isn't it? Similarly, you find all the values. Then one more thing you can say, W42 will be equal to any other terms. When you find W42, the value will be 1. Okay. So, sorry, minus 1. Value will be minus 1. Any other term with equivalent values? 42 according to this property. W42 will be equal to 2 plus 4, W46. This one. See this value. It's W46. So this will be again minus 1. W46 again minus 1. So if E center 1 keep is under, you can fill minus 1 like this. Minus 1. Here minus 1. Here minus 1. Here you will have minus 1. Right? Then here you have to find W41 that we got the value minus j. So this was minus j. Here also you will get a minus j. Here you will get plus j. Here you will get another plus j. So this is the matrix that you can use. Either you can by heart this 1, 1. Center you have a 1. Here minus 1, minus 1, minus 1, minus 1. Then this diagonal, main diagonal minus j's, and off diagonal you have plus j's. That's it. It's pretty easy to remember. Okay, now let me rewrite it over here. So this was the matrix that we are going to use. Help me to write it. 1, 1, 1, 1. Very easy. 1, 1, 1, 1. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9 positions. Middle value will be 1. Just in the 4 sides, you will have minus 1. Main diagonal, you will have minus j. This is the main diagonal, remaining terms. Then off diagonal, you will have plus j. That's it. It's pretty easy to by heart. Or you can look at this. Examiner directly apply the. Now, what was your sequence? 1, 1, 0, 0. You are going to find the 4-point DFT of this sequence. So, multiply and find the answer. Here 1 into 1, 1 plus 1. First value will be 2. Then 1 into 1, 1 minus j. So this is 1 minus j. Second term 1 minus 1, 0. These are 0. So I am neglecting all these guys. 1 minus 1, 0. Third term, 1 into 1, 1 plus j into 1 plus j. So you will get 1 plus j. So what is your answer? Therefore, x of k is equal to 2 comma 1 minus j comma 0 comma 1 plus j. From the beginning, we are using the same sequence so that you can compare the results always. Okay, that's the same sequence. Try right? We will practice that later. So you got the same result. Any confusions? Hope it's fine. Can I move to the next section?
Yes, sir.
Okay. Next thing is inverse DFT, IDFT. So let me recollect the equation of DFT once and we will find it. Okay, DFT was given like this. X of k is given by sigma. Others, please mute the mic. N equal to 0 to n minus 1. X of n e raised to minus j 2 pi k by capital N. Any problem? Error under? I missed one n, right? So this was the equation for DFT. So next thing is x of k will be given to you. You have to take the inverse DFT. You have to find for which sequence is this DFT provided. Okay, you have to find, you have to transform it from frequency domain to time domain back so that I can use IDFT. So the equation for IDFT is, so x of k is given to you. You need an equation for x of n, right? So x of n equal to sigma. Now the index will be k. K varies from 0 to n minus 1. X of k e raised to, instead of minus j, it will be plus j. Okay, this is plus j. 2 pi kn by capital N. There is one more thing to be added. Here you will have a 1 by n. Like in continuous, we have 1 by 2 pi in front of 1 by t in front of the summation or integration symbols. Likewise, here you have 1 by n, the period. So this is the equation for DFT and this is the equation for inverse DFT. Clear, Aya? Let's try one example. Hope you are noting the equation. Equation note it. We will wind up with one example. Are you ready to do that? X of n equal to 1 by n sigma k equal to 0 to n minus 1 x of k e raised to plus j 2 pi k small n divided by capital N. Repeat, 1 by n sigma k equal to 0 to capital N minus 1 x of k e raised to plus j 2 pi k small n divided by capital N. So let's try one question. The task is find the inverse DFT of x of k equal to, the previous answer was 2 1 minus j 0 1 plus j. Let's do the reverse, right? So 2 1 minus j 0 1 plus j. This is the sequence. You have to find the inverse DFT. So try to do that. You generalize the equation first. Always proceed like that. Else you have to do many substitutions. So x of n equal to 1 by n. N is 4 here, right? Because how you understood it is 4. Here you have 4 terms. That means you have calculated a 4-point DFT. If here you have 1000 terms, that means you have calculated 1000-point DFT. So n is capital 4. Got it? 1 by 4 sigma k equal to 0 to 3 x of k. This will be e raised to plus j 2 pi k n by 4, right? So 2 and 4 will get cancelled. So this will be j pi k n by 2, j pi by 2 k. That's it. So let's find first term x of 0. Substitute x equal to 0, sigma, do it yourself. X of k raised to 0 will be 1. So 1 by 4 into sum of all the terms, like we did over there. Add all these things, plus j minus j will get cancelled. 1 plus 1, 2, 2 plus 2, 4. 4 divided by 4, that will be 1. First term will be 1. Similarly, you find the other terms. Try to do x of 1. Hope you are comfortable with this e raised to j values and all. Else you can find calculator r angle theta formula calculator will cheyam. You find x of 1, x of 2 and x of 3. It's for it. Task for it. Chelo. ചെയ്തോ? Any confusions? X of 0, x of 1 will be again 1. And എങ്ങനെ തന്നെയാണോ കിട്ടുന്നത്? Small x, sorry. X of 2 will be 0 and x of 3 will be 0. So the sequence is 1 1 0 0. അങ്ങനെ തന്നെ കിട്ടണം. ഞാൻ ചെയ്യണോ? ഹലോ? ഒന്ന് റെസ്പോണ്ട് ചെയ്യൂ. ചെയ്ത് കഴിഞ്ഞാൽ നിങ്ങൾ
ചെയ്തോണ്ടിരിക്കണം.
ഓക്കെ ഓക്കെ ചെയ്തു ചെയ്തു. ടേക്ക് യുവർ ടൈം. നിങ്ങൾ ഒരു മിനിറ്റ് ഒന്ന് ഹോൾഡ് ചെയ്യൂ. നിങ്ങൾ യു ക്യാൻ കണ്ടിന്യൂ ആഫ്റ്റർ ദാറ്റ്. നമുക്ക് ടൈം വേസ്റ്റ് ചെയ്യണ്ട. ഞാനൊരു കാര്യം ചെയ്യാം. വിൽ സമ്മറൈസ് വൺ ഇമ്പോർട്ടൻറ്റ് തിങ്. ഒരു കാര്യം ഒന്ന് പറയാം. വെൻ യു ട്രൈ ടു find the DFT equation. If you can you from this can you frame the shortcut method to find using this matrix IDFT matrix method shortcut we compute here. So this was the matrix. Google search difference feel. Clarify. Okay. So this is the matrix that I used to calculate DFT. The inverse of this matrix can be used to calculate IDFT. So for example, the matrix we have calculated is referred as W matrix. So if capital X, if I have to calculate capital X, what we did W into small x matrix. Are you getting this? This is what we have done in the beginning of today's section. To get the DFT, we multiplied the W matrix with your sequence x of n. X of n and small x represented. So the question is, how can you get small x? Can I get it like this? W inverse into capital X. I'm going to try you knock up. Okay. You have to practice this. You have to just try this once. So will it work? Is it correct? You can see that the answer won't be correct because here you miss another term. 1 by n term. This will work as per our W. We design the W. This is the equation for DFT and this is to calculate IDFT. For the W which we have designed means this one. And now this is the W matrix. Is it clear? But when you Google the equation, your W will be different. W, they might have given like that, define the W matrix like this. What was our W matrix? It was 1, 1, 1, 1, 1, 1, 1, 1. Here you have 1, minus 1, minus 1, minus 1, minus 1, minus J plus J plus J. This was your W matrix to calculate a 4x4 matrix, 4-point DFT. But when you Google that, you can see another format like this. It will be written like this: 1 by 2. It's 2 because of the fact root n is the general structure. 1 by root n. This you worry just 1 by root n because they want to make this completely inverse transformable. But capital X equal to W x and small x equal to what? W inverse capital X. This will be perfectly correct if you do like this. If you modify the W matrix like this, 1 by root n. That's why many authors might have followed this format. No need to worry on that. You stick to this. Our class is curriculum answer key. So we will stick to this. Is that clear? If you have any doubts, you can ask. Problem continue. Doubt